Dr. A. Sagai Francis Brito, Associate Professor, Department of Mechanical Engineering, Royal College of Engineering and Technology. In the previous lecture, we have studied about the basics of what material is and how the materials are being classified. In this lecture, we are going to see about the classification of material testing. Testing of materials can be broadly classified as destructive, non-destructive, and the third one is the process inspections or test. In the destructive test, the components or specimen either breaks or remains no longer useful for further use. Examples: tensile test, flexural test, impact test, bend test, torsion test, fatigue test, etc. In non-destructive test, the components or specimen does not break even after being tested, so it can be used for future use. Radiography, ultrasonic, thermography, eddy current, etc. Process or inspection test. The process test comes from the type of manufacture where it is performed, such as foundry, welding assembly, etc. The first or final piece of sampling may be subjected to inspection and check inspections. Example: receiving or incoming inspection, conveyor or hopper inspection, stores and stock inspections, etc. Testing for mechanical properties. Static tension and compression test, static shear and bending test, measures of ductility, hardness testing, impact test, fracture toughness test, creep test, fatigue. So testing for thermal properties, thermal conductivity, specific heat, thermal expansion, and testing for corrosion, radiation and biological deterioration, corrosion, radiation, biological deterioration. Testing for non-destructive testing, liquids, radiation, sound, magnetism, infrared. So characteristic testing for microscopic testing. Microscopy in the sense we can go for optical microscope, scanning electron microscope, transmission electron microscope, field ion microscope, scanning tunneling microscope, scanning probe microscopy, atomic force microscope, X-ray diffraction, topography, spectrography, optical radiation, ultraviolet visible spectroscopy, Fourier transform, infrared spectroscopy, thermoluminescence, photoluminescence, X-ray, X-ray diffraction, small angle X-ray scattering, energy dispersive X-ray spectroscopy, wavelength dispersive X-ray spectroscopy, electron energy loss spectroscopy, X-ray photoelectron spectroscopy, Auger electron spectroscopy, X-ray photon correlation spectroscopy, mass spectroscopy, electron ionization, thermal ionization, mass spectroscopy, Malditov, secondary ion ion mass spectroscopy. Next is the nuclear spectroscopy, nuclear magnetic resonance spectroscopy, Mossbauer spectroscopy, perturbed angle correlation. Others: photo correlation spectroscopy, dynamic light scattering, terahertz spectroscopy, electron paramagnetic, spin resonance, small angle neutron scattering, Rutherford backscattering spectroscopy. Macroscopy testing. A huge range of techniques is used to characterize various macroscopic properties of materials, including mechanical testing, including tensile, compressive, torsional, creep, fatigue, toughness, and hardness testing, differential thermal analysis, dielectric thermal analysis, thermogravitic analysis, differential scanning calorimetry, impulse excitation technique, ultrasound techniques, including resonant ultrasound spectroscopy and time domain ultrasonic testing methods. So in the next lecture, we can go through about the purpose of testing. Thank you.